So go back to yesterday's lesson. We learned central angles, right? And we said a central angle comes from the center of the circle. And I said to think of like a round cake, and if you were cutting a slice, you would, cut it in a triangular shape, and that's a central angle. Go with me? Mm-hmm. All right. Enter inscribed angles. So I'm throwing a new angle at you. We already talked about it on the vocab sheet, if you recall. On the vocab sheet where they were all listed, we talked about two types of angles. The first one was central. This is the second one. It's called inscribed, which means if you look at this example right here, all three points that you would name the angle with, all three letters, are sitting on the edge of the circle. You see that? If you were to trace your eyes around this circle, you're going to pass through point A, point B, point C. That means it's inscribed. Not central, inscribed. With me? Look at the difference in a central angle. Don't write this. Don't write. Central would be right there. Yes?
Yes.
Okay. So there's the difference. Now, fill in the blank. An inscribed angle is an angle with its vertex, not the center, but on the circle. Which means, since the vertex is sitting on the circle, the two sides of the angle are actually called chords. Now, with a central angle, the two sides are called the radii. With an inscribed angle, the two sides are chords. The phrase intercepted arc. Intercepted. When a football player, quarterback, throws an interception, what does that mean?
Throws to the other team.
The other team doesn't throw it to the other team, guys, necessarily. What's the matter with you? Don't you know football? Just kidding. If the quarterback throws an interception, it means the other team just caught the ball, right? Okay, so an intercepted arc means where the angle is opening up to cross the circle. In this picture, the intercepted arc, I want you to do like squiggly. The intercepted arc, think of a flashlight, okay? Think of like you're holding a flashlight from right here, it's projecting, and the intercepted arc is from A to C. It's an arc that lies between the endpoints of the angle. Now, here's the new part. Here's the math behind it, okay? I hope you're listening. This little bullet right here, this is the math behind an inscribed angle. So go back to yesterday's lesson. We learned that a central angle is what to its arc? Go back to yesterday's lesson. We learned a central angle is what to its arc? Congruent or equal. Inscribed angles do not have the same relationship. There's a different relationship. Here's what I need you to write. It is half its arc. So, for instance, in this example, the measure of angle A to B to C, right here, is going to be 1/2 the measure of that arc, AC, that it opens up to. Now, here's what I want you to fill in on your notes. We're going to put an X here with a degree symbol. And then we're going to go to the outside of the circle and we're going to write something next to that shaded arc. If the angle is X, then the arc is 2X. If the arc is 2X, then the angle is 3X. Now, we need to tie it all together. Big picture. Come right here and just look. Don't write any of this down. I'll tell you what to put in your notes in a second. All right, we've got a central angle, right?
That's a great circle.
My center's off. Well, they say if you can draw a perfect circle, it makes you crazy. So, no, that was bad. So I'm not crazy. We're good. I know somebody, there's a teacher that, who is it?
Mr. Millwood.
What does he do? Is it something like takes his whole arm? Is it this? Like,
Does he actually do it right too?
no, like you go all the way around, like,
He does it the opposite.
straight. He does like that?
Yeah.
He does, no, how do you still, I don't,
Your
oh,
arm is
straight.
straight. You start here and your arm stays straight. Yeah. And then go
I'm
up.
just glad you're with me. What?
Like keep your arm fully straight.
But I go off the screen.
But you'll eventually make perfect.
But you'll eventually move out.
See what I mean?
It's not.
That's close.
It would be perfect if
Has he got shorter arms than me?
Probably.
Maybe it's pretty
Probably. What else?
Yeah.
What's that supposed to mean?
Literally.
Don't tell me.
Oh, see, I can draw.
That's perfect, Miss Holcombe.
No, it's not.
It's okay. Anyways, I'm not crazy. My mom had me tested. Here we go. That's a reference to Big Bang Theory. Please don't start running down the hallway saying Miss Holcombe said she's crazy. Look at this picture. Okay, watch is really struggling. Oh, it's spam. That's why my watch is probably like, hey, don't worry about it. It's just spam.
I could have.
Yeah, you should have let me.
Yeah. All right, look right here. The purple angle is central. The blue angle is inscribed. Y'all with me?
Really appreciate it.
Ron, do I need to move you? No, he keeps going there.
Not me. Not me.
Okay. Making this noise.
Going fly on some sauce. He just keeps it.
It's alright.
Do you have anger issues?
What them?
Okay. How are you going to remember that a central angle equals its arc and an inscribed angle is that like half double relationship? I have a very corny, stupid way to remember that works every time, and I'm very proud of it because I don't think another geometry teacher says this. Look at this. We learned already yesterday, focus on the purple angle. We learned that a central angle, right here, is equal to its arc, right? So like if this was, say, let's make it pretty, we'll say 30 degrees. Then this would be 30 degrees, right? That's what we learned yesterday. Okay, the new part for today is that if I have an inscribed angle, you do have to start tracing the edge of the angle to make sure it's going to that arc you're looking at. But if I have an inscribed angle, opening up to that same arc, if the arc is 30, then the angle would be half that, which is 15. So my question to you is, how are you going to remember that a central angle is equal its arc, but an inscribed angle is the either half or double relationship? Here's how. For central angles, right, I want you to think piece of cake. What does piece of cake imply? Easy. If it's a central angle, I want you to think it's how you would cut a piece of cake from round cake. Like you would cut a triangular slice. So it's a piece of cake. It's easy. If it's an inscribed angle, this is the new part. I want you to think snow day. I'm going somewhere. Listen, here we go.
This is where the corny part.
This is where the corny part comes in. Do you remember the phrase, what I always say, go to what you know? Right? Okay. Once again, for this whole unit, go to what you know. Always start from where you know something. Okay? So let's pretend like I have an inscribed angle and they gave me the angle. Let's say it's 20. And then it says right here, what's x? Okay, if I go to what I know, then I'm going to start with the angle, right? Y'all with me?
Yes.
Because we're fixing to practice this. This is the lesson. We're fixing to practice it. So if you miss this, you're going to miss the lesson. Go to what you know. The angle's 20. Pay attention to what kind of angle. Is it how you would cut a cake?
No.
No. So it's inscribed. If it's a snow day and I'm in the house and I'm going outside to play in snow, I would do what with my layers? I would double my layers. So the outside would be 40.
Right.
Now let me show you the reverse. What if it's an inscribed angle and they give me the outside? I'm making this up. Well, you would go to what you know. I know that. Where am I? I'm on the outside. I'm coming inside. If I've been out in the snow playing and I come inside, I take my jacket off. I half my layers. So half that would be 30. So that's what I mean by think snow day. Go to what you know, and then look at where you need to go as far as like finding x, and ask yourself, if it was a snow day and I was going outside, I would double. If I was coming inside, I would half. Does that make sense? No?
Yes.
It makes complete sense, I promise.
Well, let's practice it. So here's what I need you to do on your paper. How much room do we have? Let's see. You've got the very top or you've got the bottom. So either go to the very top or go to the very bottom. And the stuff that's in green needs to be on your paper. Find some space to copy what's in green. And then we do have those 2 boxes left to address, and then we're going to start the problems. Oh, they left it for snow. Guys, can y'all quit?
I thought you were.
Right, I'm gonna make you go back to your seat if y'all can't stop.
You just completely understand.
No, I didn't.
Okay, wait, I gotta copy this one.
Yeah, copy this down and then we're gonna start practicing. You probably can go ahead and answer number 1.
Yeah, number 1's 21.
Number 30.
Number 1, I miscalculated.
I need to show you the next box in the notes at the top before you can do number 3.
What's number 2? Get number 5.
There's several you can do.
You can do it.
You can do it. All right. Has everyone got the green stuff down? Because now I need to go. Oh, snap.
What? I'm almost
What?
done. Can you do number 4?
Well, I will gladly help. I just need to. Ow, Abby, you just turned right into my tummy. I just need to finish the notes.
Oh God, that's what.
I'm so sorry.
Abby just swung that swivel chair
Sorry.
right into my gut.
I'm sorry. You're gonna have.
Sorry, doesn't cut it.
You know what? My appendix does hurt now.
It burst.
Don't say that. You could die if that happens.
Hey, why do you always
She
have to
was
take
just making,
examples?
she was making a joke.
Really?
She was feeding off the joke that I made. Alright. Go to this. We've got 2 things left to discuss before we take off with the practice problems. Look at the next box. This says, what if you have a problem where there is a diameter? Notice the diameter drawn is the endpoints of angle CAB. Look at the angle. Think of an angle as like rays of light shining out. Notice the endpoints of the angle are the endpoints of that diameter. Do you see that? Okay, something special happens every time this happens. Sorry, let me rephrase that. That was repetitive. Something special exists every time this situation comes up. And I don't want to just tell it to you. I want to see if you can get there because I feel like you can. What did we say diameters do?
Equal 180.
They cut the circle in half, which means you have 2 180s, right? So diameter, remember, creates. I don't have room to write semicircle, so I'm going to write creates 180. So I'm going to go over here to the side that the angle is not on, so it's less crowded. So this angle is opening up to this arc, correct? And that arc is a semicircle, right? Do you remember a semicircle is when it's exactly half the circle? Yes? So how many degrees is it? Now, was it a central angle or an inscribed angle? This is inscribed. All of these are inscribed. Which means, go to what you know. Okay, I know the arc. If I'm coming inside, am I doubling or halving? I'm halving it. So if I'm coming inside, it would be 90, which means I can draw a right angle. And that's what exists every time an inscribed angle is opening up to a diameter. You have a right triangle secretly in your problem. Every single time. As long as, let me make one small disclaimer because I've seen it before one time. As long as all 3 letters of the inscribed angle are in fact on the circle, and the first and the last letter are the diameter, then it's every time. So if an inscribed angle intercepts the diameter, then it is a right angle, which means it measures 90 degrees. Now the next one is kind of common sense, but the picture looks really weird at first. Caleb, are you writing this down? Because your lunchbox is strategically placed that I can't see. I know that. Just checking. Abby, you gotta find the silent one. Okay, look at this picture. Looks really complicated, but it's not. Here's why. When you first look at it, you probably get overwhelmed because of so many lines. Can you tell me how many actual inscribed angles are in this picture?
No, there's 2.
There's 4. Do y'all see them? You've got, I'm going to trace them. Ready? You got 1, 2, go reverse, 3, 4. Yeah? Okay. So you have 4. I want you to focus on just 2 of them. Doesn't matter which 2. So I'm going to focus let's see, angle ABD, ABD. All right. I'm going to focus my attention on this one right here. Yes? Okay. Can you tell me what arc angle ABD is opening up to? It's opening up to AD, right? Can you tell me another angle that's opening up to arc AD? ACD. I'm going to change to green. Angle A to C to D is opening up to the exact same yellow arc. This little box is saying to you, hey, if you ever have a problem where more than one angle inscribed is opening up to the same arc, well, if their arcs have to be equal, then what do you know about the angles? The angles would have to be equal, and that's what you would need to draw. That this here is going to be congruent to this here. Okay? You with me? I'm not kidding, guys. I hope you're listening.
I am.
All right, so if two inscribed angles intersect the same arc, then they are congruent. So in this case, the measure of angle ABD will be equal to the measure of angle ACD. And I'm going to highlight the two letters that matter here. Notice A and D match in both of them. That has to be the name of the arc that they have in common. The first and the last letter have to be the arc they have in common. Okay? Alright, so that's all for the new stuff. Now let's put it all together and practice. I love these worksheets because they start out very simple. One step, plain numbers. Then it goes to, okay, now we're going to throw some algebra in. And then when you get to the end, it's all algebra multi-step. So they are going to get progressively more challenging, okay? So let's look at the first couple. Number one, remember what I said. Go to what you know, and it also helps if you now start putting like question marks where you're trying to find something. So you kind of keep in the back of your mind like where the goal is. So this says that arc WY is 62, right? And then it asks me to actually find what? It says to find angle WXY. So it's talking about right here. I'll put a question mark. So what would it be? Did you get 31? If you ever forget the snow day analogy, right? Let's say you forgot it. Or let's say for some reason you doubled. Is there any way, shape, or form that that angle is 124 degrees? No. So if you forget the snow day analogy, when you go and you mess up, it should like not make sense at all, okay? The snow day analogy, if you're still struggling with what I was suggesting, if you start with what you know, I'm on the outside of the circle, right? And I'm coming in. If I'm coming in from playing in the snow, I'm going to take all my layers off, so I'm halving it. So it would be 31. Now I'll go to number 2. Find the arc they're telling you to find and highlight it. So from D to G to F. So D to G to F. And I'm going to put a question mark. Then I'm going to go to what I know. What do I know?
The inside.
I know the inside's 113. That means I'm going out to play in the snow, so it would be
226.
226. Make sense? All right, number 3. It says, find the measure of angle PQR. Your first instinct is probably to say, how am I supposed to do this when there's not a single number on the picture? Remember I said look for diameters, because a diameter is secretly telling you there's two 180s there. And the new part from today is that, hey, that's a diameter, so that, it helps to label, is 180, which means coming in, this would be 90.
Wait.
Let's even half it. Half 180. Oh. All right. Go to the next one. Number 4 says find the measure of arc BC. This is why it helps to highlight B to C. Okay, now go to what you know. What do you actually know? You know from here to here is 47. Okay, these questions are now stepping up a notch to like more difficult. The 47, think of the flashlight. Does the angle 47 open up to BC?
No.
No. Which means that 47 opens up to AC to be what though? Like to measure, I'm sorry.
Oh,
So
94.
you double it, it'd be
Uh-oh. Uh-oh. Uh-oh.
it would be 94, right? And then now look and see, it's a puzzle, y'all. There is a diameter there. That's a diameter, so that's what? 180, and you're just missing one chunk. 180 minus 94 is,
160.
I think you went the other direction, like 90, 180 minus 90 puts it at 90 minus 4 more. I think you just typed it wrong. 86. There you go. All right, let's do the next one. Angle JKL. J to K to L. So this is J to K to L. So this is my goal. Okay, here's a great question where sometimes your goal is not your starting point. Like I can't tell you the goal answer just yet. I've got to play around with the picture. Always check an angle to its arc or its arc to an angle. Like always check those two first before you just start jumping around the picture. I don't know this, right? Go to its arc. Trace the edges. Be careful. So the edges would be L all the way to J. Do I know it? Off the top of my head, no. But can I find it?
Yes.
If you pay attention to that whole circle, you know the rest of the circle, right? You know the 53 and the 65. So the only chunk missing is the one I just shaded, which is why shading really helps. It helps you to see like when that's the only piece left or if that's the only piece given or something. All right, so 360 minus 53 minus 65 is what?
240.
So that's what goes there. And then now you know the arc. You're coming in, cut it in half, and it's 121. All right, let's go to 6. 6 is one of those where there's multiple angles, and they open up to the same arc, which means there's congruent angles hidden in there. All right, so this says find the measure of angle R to S to T. R, S, T would be right here, right? Now find the measure of angle R, U, T. R to U to T is here. But what do you notice about both of those angles? Think of two spotlights. Those two spotlights are both shining to arc RT. That means the angles have to be equal. So once we know the arc, then we know the angles. Now look at your picture. Is there a diameter in this picture? No. Careful. It's got to go right through the center. Guys, when there's no diameter, this happened on that sheet yesterday, which some of you haven't turned in and I need it. It was great.
What?
81, the back.
I got it.
Wait,
Turn it in, it's great.
I thought I showed it.
If you showed it to me, I got that grade. But there was several people who never came up to my desk. So if you're one that never came to my desk, I didn't get your
Wait,
grade.
you actually not have my picture.
No, I think I told you to keep them.
You did, you gave them
I did. I have grades only from people who came to my desk. All right, so yesterday on the sheet, when you got towards the end, some of the problems had no diameters, and a lot of people are like, I don't know how to set it up if I don't have a diameter. If there's no diameter, odds are it's the entire circle approach, which is 360, which is the case here. So you would take 360, because that's all the way around. You would subtract off these pieces that you know, and you'd be left with the one chunk that we're missing. And somebody tell me what that is.
That's 82 right here.
And if that's 82, it's a snow day, the angles would be,
41.
thank you.
I think this is a snow day.
Okay, for questions 7 through 12, we are beefing it up a notch. I'm gonna work with you on a couple in this level of difficulty and then one in the next level of difficulty. Look at 7. The reason these are more challenging is because now instead of just numbers, there's an algebraic expression. Don't let that throw you off. It's the exact same approach. The tip, the technique that I would suggest is to look at it and ask yourself, how many degrees would be in the piece that has the algebra? And then that's what you set it equal to. So here we go. Solve for x. Go to what you know. I know this is what? 158, right? From here to here is 158. That's what I know, correct? Go with me? Following? I feel like I'm losing some of you. If that's 158, come inside the circle, then the angle that it opens up to, that creates it, would measure, do I half it, double it, or equal it?
Half it.
I half it. What's half 158?
79.
So that angle has to be 79. Now you've just created your equation. 8x minus 9 has to equal 79, and that's what you solve. What'd you get here?
11.
You do what to both sides here to solve? Add 9 to both sides. Right? Okay, I'm going to leave 8 for you because it's simple approach. Go to 10. Go to 10. Question. Does question 10 have a diameter?
No.
No. Be careful. I've seen people try to make diameters when they're not actually there. So because there's no diameter, you cannot do the whole 180 concept. All right, so look at it. We've got a lot going on here. since we cannot do 180, what approach did I tell you to check for? When you can't go 180, check for 360. Can you get something for all the way around the circle? Because if you can, then they have to add up to 360. So if you look at this picture, they give you enough information that you can go and label those missing chunks around the circle. It's going to be snow days. So you just have to be careful and label the correct thing. Think spotlights, okay? Think of like a giant Batman signal spotlight that is shining, and think of like the rays of the edges, and then you've got your arc, okay? So the 114, it helps to draw an arc, because then you can see where the edges of it are going to. So the 114 is going to open up to what two letters?
Y and W.
Yes, it's going to open up to Y and to W, which means it's creating this arc over here, correct?
Mhm.
So if the angle inside is 114, going outside in a snow day, it would be 228. Now, do I have all of the edges of the circle? No, not quite. I need to go find the one missing. Now, this one's not going to help me, right? Because I don't actually know what it is. I don't know what X is. So instead of trying to double that and set that equal to the sum of all of them being 360, why don't you just find the measure of that arc? Can I find the measure of that arc?
Mhm.
Yeah, because if you look at the circle, that's the only piece missing, right?
Yeah.
So how do I find the measure of that arc?
228 plus 78, and then you get your sum, and then minus that from 2.
Perfect. So if you notice going all the way around the circle, I know everything but the question mark. So I'm going to do 360 minus 78 minus 228, and that leaves me with
54.
54.
Why did you not just do 7x plus 6 plus 9
I see the approach you're going. Let me finish the way that I'm going, and then I'll actually touch on that, because that approach also works. And this is the only annoying thing about teaching circles is a lot of times people see it a different way, and it's actually not wrong, but I can't highlight every way on every problem because we'd be here forever. So hold on a second. So now I know the arc is 54. I know the arc's 54, so coming inside, the angle would be 27. So I don't have a lot of room right here, so I'm going to actually, where this arrow is pointing, I'm going to say that this has to be 27 degrees. So there's your expression that you would set up. 7x plus 6 has to equal 27. All right, now that's one way. Brooklyn pointed out something different, and I'm just going to redraw the picture here. Right? Oh. Okay, original picture. While I took the approach of all the way around the circle, has to add up to 360. There's a second approach here, and it has to do with a triangle. Triangles, angles have to add up to 180. But do I know all three angles of the triangle in the picture? No, but can I find it? Look at the angle that's missing, right here. Follow the spotlight. It opens up to 78. So coming in, half of 78 would be, what is that, 39? Is that right? So then I could say, okay, 114 plus 39 plus 7x plus 6 has to equal 180 because it's a triangle. Totally different approach. It works.
I have a question.
Yeah.
On 13. So, can you just,
On 13?
okay, this is 13.
No, I'm on 10.
Oh.
I'm going to 13 right now. So stand by.
Oh, yeah.
Did that help with 10? That was the second approach for 10. If you wanted to use the triangle, that whole like the angles of a triangle added to 180. That is true in all these problems. Okay. All right. Let me take that off though, because that was 10, not 13. I just wrote it down here. Okay. You should be good with these. I need you to brainstorm. Okay. I don't want to help you on every one of them because then I'm taking away all of the thinking. The next section of questions, 13 through 16, are the same level of difficulty. They involve more algebraic expressions. You have to set an equation up and solve for x before you can answer the question. You will notice that not one of these says find x. You notice that? You have to find x first on every single one of these. Like here, find x. Here, find x. Here, find x. My two people that like to not show any work. You have to show work and find x, because then after you get x, you have to find what it actually tells you to find over here and tell me what it is. Okay? So make sure you're showing me this right here, so if you get x wrong, I can see why you got it wrong. All right? Now let's work 13. Okay. It really helps to label your picture. They did not label any of them. FGH. F to G to H, the angle, is 6x plus 21. Right? This is really hard to label on this board. From here to here is 6x plus 21 degrees. Okay. Arc, F to J to H. So F to J to H is 17x minus 28, right? Find x first, then find measure the arc. Okay, what's the relationship there? What type of angle is drawn? Central or inscribed? That is an inscribed angle, which means it's a snow day. Right? Okay, which part gets doubled? Think about it. Think of where do you have to be to double it? You have to be on the inside. Wait a minute. If I say go to what you know, and you were about to double the number, then where would you have gone? You would be on the inside. Go with me? And then you would double that number to be the outside. So I'm going to double the angle to equal the arc. Does that make sense? Yeah. Oh. Yeah, you're just going to set it. It's time. Oh, yeah, you can just double the angle. So the angle is 6x plus 21. Make sure you put it in parentheses. And the arc is 17x minus 28. Now, when you go to double that, you have to remember to do what with that 2? Distribute. Now you have a good old-fashioned multi-step problem on your hands. Fine. Huh? Don't get it? Sorry. post those numbers, didn't I? What do you mean you don't get it? Because you gotta understand something that I'm doing. You can't just be like, you can't not know a single thing. What do you? Well, no, I mean, that's what I'm here for. Did you? You gotta, so it helps if you're highlighting and labeling as you go. Is that gum?
No.
Okay.
I don't know how to solve that.
You guys saw, what do you mean you don't know how to solve it?
After I get
Plug it in. What did it tell you to find? The arch.